Hello everyone. Today we are solving another LeetCode question. LeetCode question number 100. The problem number is the same tree. In this problem, you are given two different trees and you have to tell if both trees are exactly same or not. So seems an easy problems. There are three different use cases are given. Let's first try to evaluate these three use cases and then accordingly we will try to build the strategy to implement the answer to this question. So let's start with these three diagrams. First, we can start with the top one. Are they equal? So how we are going to compare this? So first, let's say this is the root for root 1 and this is the root 2. What you are going to do here? First, you are going to compare if both are equal or not. So seems both are equal. So the condition met. Now, what exactly the second thing you want to compare? Whatever is the left of this tree should be equal to the left of this tree. Now, first thing we are going to compare, are they equal? Answer is no. So it means these two trees are not equal. Not equal. But what exactly you have compared here? So you try to see here the value is not null, but one of the child is null. If either both the child are null, then it makes sense the both are equal. But if one of the child is not null, another is null, that in that case we can consider they are not equal. Now let's try to solve this problem. In this case, this pointing to your root 1, this pointing to the root 2. Are both equal? Answer is yes. Now we are going to again solve this problem recursively. So we path solve for this, let's say left child, this one. Again, this is your root, this is your root. No, not exactly root, but this is kind of the virtual root because you were again trying to solve the sub problems. Now, are they equal? Answer is yes. Then here we go try to solve for this child null. Here we try to solve for this null. Both equal? Yes. Similarly, we try to solve for this null and this null. Both equal, both equal, both equal. Okay. So we compared this, these are equals, and eventually we try to solve the problem for this child. We say that both are equal, yes. Then eventually we can say that the both of these three are exactly same. Similarly, let's try to solve this problem for R1 and let's say R2. Both are equal, yes. Then compare the left child, we find the values are different, and eventually we say that, oh no, these are not. But overall idea how we actually solve this problem. So for two trees, we are given a root R1 and R2. What we have to check? We have to check if both are null. So let's write the cases here, R1 and R2. Okay. So let's say both are null. In that case, we say that the trees are both the trees are at least both the nodes are same, right? Now one of these two is null. This is null, but this is not null, or other way around. In that case, we say that yeah, itself says that both tree cannot be same. Third case, when both are not null, not null or not null. Can we say both the trees are exactly same? No, exactly no. So then we have to compare the value. Let's say here the root has the value v1, this one also has the value v1. Then only we can say both the same. Now, once we say that the both of root are the same, it does not mean the tree is same. Now we have to solve the problem for the left subtree of this and similarly left tree of this. Similarly, then we try to solve the problem for this right and this right. If this part, okay, let me change the color here. If this part is exactly gives these two are same, and let's say these right child and these right child say the same. Okay. Now based on this table, root is same, left child is same, and the right child are same. So of all these conditions met, then eventually we say that the trees are same. Now let's try to write this in the code. So same. So we are given the two nodes P and the Q where we taken the R1 and R2. Here the P. If P is equal to null and Q is equal to null. So we say return Q. Okay. Now why we are not solving the child case problem here? Because P is null, Q is null. We said that we reach the terminational conditions. There cannot be further child because node itself is null. Now the second case, if P is equal to null or Q is equal to null, return false. Now look at this condition. If you're looking at this condition, what are the different possibility? P is equal to null, Q is equal to null. So this condition covers the three cases. Either P is null, either Q is null, or both of the null. But when both of the null, why we are returning false? Because that condition we have already here handled here. The conditions remain here. Only the cases where either P is null or either Q is null. So we are returning the false. But if we pass both of these conditions, it means neither P is null, neither Q is null. Now what we have to compare the value. If P dot value not equal to Q dot value. So here we can say that directly false. If root itself is not matching, then we don't have to compare the subchild. We say that, oh, both tree cannot be same. Now, if all these conditions satisfied, then we have to compare for the subchild as well. Is same tree, P dot left, Q dot left. Here, what exactly should I put? Is same tree, P dot right and Q dot. Now, should I put here or and? So now we have to say, for example, what exactly we said it. Both the root should match, left child of the first tree should match the left child of the second tree, and the right child of this first tree should match the right child of second tree. So all these conditions should satisfy. Root we have already matched based on these conditions. Now the conditions here is that we have to compare the end values. So this should run. So let's try to run this problem on the test cases. Now try to submit this problem. Okay, so we have solved this problem. Time complexity, I will say you should think about it, but eventually what exactly you're doing, you are trying to traverse every single node of one tree, compare with every single node of the another tree. If both the tree has the same number of the nodes, so then the overall complexity is the order of n. Let's say first is m, second is the n. Where exactly you're comparing? I mean, it should be, I would say, minimum of m or n. That is the overall complexity. So thank you for watching this video, and I will try to publish videos on another questions as well. Thank you.